Students, we are discussing factors affecting enzyme activity. Factors affecting enzyme activity, right? What are the factors that affects enzyme activity, sir? Number 1, temperature. Number 2, pH. Number 3, substrate concentration. Number 4, enzyme concentration. Number 5, product concentration. Number 6, inhibitors, chemical inhibitors, okay, which inhibits the enzyme activity, right? In yesterday's session, we completed temperature and pH. Now we are going for the third one, that is a substrate concentration. What it is? Substrate concentration. What it is, sir? Substrate concentration. Substrate concentration. Okay. Now listen here. Sir, here I am taking 4 enzyme molecules. How many enzyme molecules I am taking here? 4 enzyme molecules I am taking here. 4 enzyme molecules. See, sir, these are 4 enzyme molecules. Each and every enzyme, right, having its own active site. What is this called as, sir? Active site. Active site. Here, how many enzyme molecules are there? 4 enzyme molecules. 4 enzyme molecules. 4 enzyme molecules. Each and every enzyme is having its own active site, right? Now here I am taking, right, 2 substrate molecules. How many substrate molecules, sir? 2 substrate molecules. 2 substrate molecules. Sir, this is a substrate molecule, sir. This is also a substrate molecule, sir. Therefore, how many substrate molecules are there at present, sir? 2 substrate molecules. 2 substrate molecules. 2 substrate molecules. Sir, these 2 substrate molecules, one substrate goes and binds in the active site of this enzyme. Another substrate molecules goes and binds in the active site of this enzyme. It means now the active site of this enzyme is saturated by substrate molecule. The active site of this enzyme is saturated by substrate molecule. It means now how many enzyme molecules are saturated? 2 enzyme molecules are saturated. By what? By 2 substrate molecules. Okay. Sir, at this condition, right, how many enzyme molecules are still free? It means how many enzyme molecules are not saturated with substrate molecules? 2 enzyme molecules are not saturated with substrate molecules. So initially, if you increase the substrate concentration, what happens? Rate of the reaction increases. Sir, initially the concentration of substrate is low. As substrate concentration is low and the number of enzyme molecules are more, increase in substrate concentration increases the rate of reaction. Okay. Sir, in this case, 2 substrate molecules binded in the what? Active site of 2 enzymes. Still, 2 enzyme molecules are free. Okay. Now, if you increase the substrate concentration, what? Substrate concentration, substrate. What happens? This substrate goes and binds in the active site of this enzyme. This also goes and binds in the active site of this enzyme. Therefore, initially, increase in substrate concentration increases the rate of the reaction. Why, sir? Because initially, number of substrate molecules are less. So what happens? All enzyme molecules are not saturated with substrate molecules. It means some of the enzyme molecules are free. So increase in substrate concentration increases the rate of the reaction. Initially only 2 substrate molecules participated. Initially only 2 enzyme molecules participated in the reaction, but now 4 are participating in the reaction. So rate of the reaction, what happens? Increases. Is this statement okay? Right? Therefore, I am writing the statements here. What happens, sir? Initially, what? Initially increase in what? Substrate concentration. Increase in substrate concentration increases what? A rate of reaction. Increases the rate of reaction. Sir, rate of reaction can be even called as velocity if what is specified, direction is specified. Rate of reaction can be even called as what, sir? Rate of reaction is even called as velocity if direction is specified. Sir, initially if what increases? Substrate concentration increases, rate of the reaction increases. Why, sir? As some enzyme molecules are free. What are free, sir? Some enzyme molecules are free. Okay, therefore initially increase in substrate concentration increases the rate of the reaction as some enzyme molecules are free. Now listen the statement. Sir, initially only 2 substrate molecules are there, sir, having 4 enzyme molecules, sir. These 2 substrate molecules binded in the active site of the 2 enzymes, sir. It means in this case 2 enzyme molecules are saturated with substrate molecules. Still 2 enzyme molecules are free. So we increased the substrate concentration. These 2 substrate molecules binded in the active site of the active site of these 2 enzymes, sir. Active site of these 2 enzymes. Now you tell me, is this enzyme free? No, substrate has binded. Is this free? Substrate binded. Is this 2 free? No, substrate has binded. It means once all enzyme molecules are saturated with substrate molecules, saturated with substrate, saturated with substrate, saturated with substrate, saturated with substrate. Once all enzyme molecules are saturated with what, sir? Substrate molecules. Okay, right, then rate of reaction will be maximum. When the rate of reaction is maximum, when all enzyme molecules are saturated with substrate molecules, then rate of reaction will be maximum. Rate of reaction is maximum when all enzyme molecules are saturated with substrate molecules, right? Therefore, rate of reaction becomes maximum when, sir? When all enzyme molecules are saturated with what, sir? Substrate molecules. When all enzyme molecules, it means how many enzyme molecules we are taking. I am speaking about that enzyme molecules. When all enzyme molecules are saturated with what? Saturated with substrate molecules. Substrate molecules, then rate of reaction, then what? Rate of reaction becomes maximum. What becomes maximum, sir? Rate of reaction becomes maximum when all enzyme molecules are saturated with substrate molecules. Now you tell me, sir, all enzyme molecules are saturated with substrate molecules, sir. It means now no enzyme molecule is free, sir. I increased the substrate concentration. Is there any change in rate of reaction? No. Why? Because already all enzyme molecules are saturated with substrate molecules. This substrate binded in the active site of this enzyme. In the active site of this enzyme, the substrate has binded. In the active site of these 2 enzymes also, substrates binded. No enzyme molecule is free. No enzyme molecule is free. Okay. So once all enzyme molecules are saturated with substrate molecules, further increase in substrate concentration, no change in rate of reaction. No change in rate of reaction. Why? As no enzyme molecule is free, because all are saturated. Okay, right? I am writing the statement. Once Once all enzyme molecules, all enzyme molecules are saturated with all enzyme molecules are saturated with what? Substrate molecules. Further increase in what? Substrate concentration. Further increase in substrate concentration, right? Does not change. Just I am writing no change. Does not change. Just no change in rate of reaction. Does not changes rate of reaction. No change in rate of reaction. Why, sir? As no enzyme molecule is free. What is the reason? As no enzyme. This statement is important. As no enzyme molecule. As no enzyme molecule is free. Is it okay? Right. Therefore, okay. Therefore, sir, as no enzyme molecule is free, even though you increase the substrate concentration, there will be no change in the rate of the reaction. No change in what's the rate of the reaction, even though you increase the substrate concentration. Why, sir? Because no enzyme molecule is free, where the substrate can bind. Is it okay? Now, see this statement once. Sir, in this example means 4 enzyme molecules, 4 substrate molecules. In this case, when the rate of reaction will be maximum, sir? When all 4 enzyme molecules are saturated with substrate molecules. When all 4 enzyme molecules are saturated with substrate molecules, then rate of reaction will be maximum in this case. It means how many substrate molecules are required to attain maximum rate of reaction? In this case, 4. Yes or no? 4 substrate molecules are required. In this case, 4 substrate molecules are required to attain maximum rate of reaction. Sir, rate of reaction is also called as velocity. What is specified? Direction is specified. Therefore, in this case, when you will get V max, sir, V means velocity. When we are going to get V max, sir, when we are going to get V max? Sir, what is the meaning of V max? Maximum velocity, maximum rate of reaction. In this case, we are going to get maximum rate of reaction, maximum velocity if substrate molecules are 4. If substrate molecules are how many, sir? 4. I don't want a maximum rate of reaction. I want only half of the maximum rate of reaction. If I want half of the maximum rate of reaction, then how many substrate molecules I want? Only 2. To get maximum rate of reaction, 4 substrate molecules required. Maximum 4 substrate molecules. Half of the maximum, half of the maximum, only 2 substrate molecules. 4 half, 2. Number of substrate molecules required to attain half of the maximum velocity. Vmax means maximum velocity. Half of the maximum velocity I am speaking about. Therefore, substrate concentration required to attain half of the maximum velocity is called as Michaelis-Menten's constant, represented by Km. Therefore, what is the meaning of Km, sir? Michaelis-Menten's constant. Nothing but substrate concentration required to attain half of the maximum velocity. Therefore, Km is equals to 1 by 2 Vmax, or Km is equals to Vmax by 2. Right? Therefore, is this statement clear? Right. Now I am writing the statement. Substrate concentration. What it is? Substrate concentration. Substrate concentration required. Substrate concentration required to attain. Substrate concentration required to attain what? Half of what, sir? Substrate concentration required to attain half of the maximum velocity. Half of the maximum velocity. Half of the maximum velocity is called as what? Michaelis-Menten constant. What it is called as? Michaelis-Menten constant. Michaelis-Menten constant. Sir, this Michaelis-Menten constant is represented by Km. Represented by what, sir? Km. Therefore, Km is equals to what, sir? 1 by 2 V max. 1 by 2 V max. It can be also written as Km is equals to V max by 2. That is maximum velocity by 2. Yes or no? Right? V max by 2. Sir, this Km, that is Michaelis-Menten constant, right? It represents, okay, it represents inverse relation between enzyme affinity with its substrate. Inverse relation, okay, inverse relation between enzyme affinity with its substrate. Inverse relation. Therefore, what it is, sir? Km. Km represents what? Inverse relation. Inverse relation between what, sir? It represents inverse relation between enzyme affinity with its substrate. In the textbook it's given as a given substrate with its what, sir? Substrate, with its substrate. Therefore, inverse relation between enzyme affinity with its what, sir? With its substrate. Okay, what does it mean, sir? What does it mean? It means if Km value is low, then enzyme will have more affinity towards the substrate. Sir, enzyme will have more affinity towards the substrate when if the Km value is low. Inversely proportional, no? Inversely proportional, no? Inverse relation there. Therefore, if Km value is low, then that enzyme will be having more affinity towards the substrate. We want that only, because substrate should be converted into product. So enzyme should have more affinity towards the substrate. Therefore, Km value of an enzyme should be low. Km value of an enzyme. Km value of an enzyme should be low. What should be low, sir? Km value of an enzyme, it should be low. Km value of an enzyme should be low. Is this statement okay? Right. Sir, why Km value of an enzyme should be low, sir? If Km value of an enzyme is low, then enzyme shows more affinity towards the substrate. If Km value of an what? Enzyme. If Km value of an enzyme is low, then that enzyme, which enzyme? The enzyme whose Km value is low, that enzyme shows what? More affinity. Shows more affinity more affinity towards the substrate. Towards what, sir? Substrate. Therefore, Km value of an enzyme, if it is low, then the enzyme shows more affinity towards what, sir? Substrate. Okay. Catalytic activity of an enzyme. What it is? Catalytic activity of an enzyme is represented by Km and TON. TON. There is a turnover number. Turnover number. Right? Catalytic activity of an enzyme. What it is? Catalytic activity. Catalytic activity of an what's a enzyme? Catalytic activity of an enzyme, right? Represented. Catalytic activity of an enzyme is represented by what and what, sir? Km and TON. We already discussed about Km. Now we are going for TON. What is, sir? TON. Turnover number. Turnover number. Okay. Sir, TON, turnover number. Turnover number. What does it mean? Number of substrate molecules converted into products by one molecule of enzyme in 1 minute time or 1 unit time is called as a turnover number of an enzyme. Therefore, what is the meaning of turnover number of an enzyme, sir? Number of substrate molecules. Number of substrate molecules. Number of substrate molecules. Number of substrate molecules converted. Number of substrate molecules converted into what? Converted into products. Converted into products by one molecule of enzyme. By one molecule of enzyme in how much time, sir? In 1 minute time. In 1 minute. 1 minute. 1 minute. That is 1 unit time. Okay, this is called as a turnover number of an enzyme. Therefore, number of substrate molecules converted into products. Number of substrate molecules converted into products by one molecule of enzyme. One molecule of enzyme in 1 minute time. In 1 minute time. This is called as a turnover number of an enzyme. Sir, the turnover number of enzyme should be high. Km value of an enzyme should be low. Turnover number of an enzyme should be high. What should be high? Turnover number of an enzyme should be high. Because turnover number means number of substrate molecules converted into product. If turnover number is more number of substrate molecules can be converted into a product. Converted into products. Yes or no? Therefore, turnover number of an enzyme should be high. Turnover number of an enzyme. Turnover number of an enzyme, right? Turnover of number of an enzyme should be high. Okay. For example, you take a carbonic anhydrase. What is the enzyme name, sir? Carbonic, right, anhydrase. Carbonic anhydrase. Okay. Sir, the turnover number of this carbonic anhydrase is 360 lakhs. How much, sir? It is 360 lakhs. 360 lakhs it is. 360 lakhs. Okay, right? Whereas if you take a catalase, what is the enzyme name? Catalase. Its turnover number is 50 lakhs. What is its turnover number, sir? 50 lakhs. If you take flavoproteins, we are discussing some important examples. Okay, if you take flavoproteins, right, its turnover number is 50. What is its turnover number? 50. Its turnover number is 50. Okay, right. Therefore, for carbonic anhydrase, the turnover number is 360 lakhs. For catalase, the turnover number is how much, sir? 50 lakhs. Whereas for flavoproteins, right, the turnover number is how much, sir? 50. Right. Thank you.